You are on the air.
Okie dokie, right. Hello, hello. My name is Francis Edwards, and I like to help out Ryan and Diane on their various meetups. And something that I think spoke about 4 weeks ago was that I was in the middle of doing some performance working out. I've recently joined a new project. Well, I say new project. A project started without me. And then with 2 weeks to go live, they said, hey, we've got a few problems. Come over to Germany. So one of the things I was looking at was performance issues, and I just quickly whipped up a custom policy to help me measure it. So let me explain the context of what I was doing. On screen, I'm showing you Anypoint Visualizer. I hope some of you guys are familiar with Anypoint Visualizer. You'll notice a few gray bars. There's experience layer, process layer, system layer, and platform. And I've already set up my demo applications just to be able to show you what I'm going to be demonstrating. So the applications I'm particularly interested in today is this OAuth module proof of concept and this Hello World implementation. So I'm looking at how do I measure points on traffic. So you can see there's no traffic at the moment, and that's because I haven't actually kicked off any calls. So this Hello World application and this OAuth PC, I've got a Postman post to it. So I can send a request to my hello world. If I just try a request, it's probably going to say error because I haven't got a token. So what I need to do is go to the authorization part, request myself a new bearer token, use that token, and make the same get call again. And this time I get the response that I want, which, because I'm going to resources endpoint, I just want a collection with one object in, and this is just capturing the information about the Hello World application. So it's just capturing all the attributes, any variables, and timestamp and correlation ID. So that application is just this one here, Hello World. In a moment, you'll see, if I refresh this, you'll probably see a little line go from external traffic straight to that Hello World. That is locked with that's got a secure policy on it, OAuth token generation, so I have to get an OAuth token for that. This application, the experience layer, has a HTTP requester to this application and doesn't have an OAuth token requirement. So if I go back to Postman, you see I have another application OAuth module, proof of concept, and just a check endpoint. If I send that, it'll get the same response to the hello world, but this time what's happened is that it's made a call from the external traffic to this application, which has then made a call to the hello world. So if I refresh that, maybe that might show the lines. Yeah, not yet. The visualizer takes a little while to pick up metrics because they're going through Runtime Manager and posted in a bit. So I just wanted to show what I'm going to demonstrate. Now, when you're doing performance monitoring and trying to work out how fast things are going, you typically want to add in logging points. So I'll show you what logging points I've got for this application. If I for this application, I have a log at the end of the GET request, and that log is showing up in my Datadog. So if I just show you the last 15 minutes, I'm looking at this Hello World application and the OAuth module, and I'm just going to my particular index, and you can see that there's been a couple of calls. So you can see that the first call I made, which the Hello World, would give you this log. So it's a standard logger within the flow. Oh no, that's OAuth module. And it's going out to the Hello World. This one is the Hello World application. No, it's not. It's the OAuth module again. In fact, have I got a logging endpoint? Yeah, there we go. There's the Hello World. So you can see that the first experience layer had a logger, and that's the start. Did I put a start in there? I think I called it. So that's an application log. And yeah, there we go. The timestamp is when it started. It then goes to the process layer. It goes out to the process layer, which is this one. And it's the hello world. I have just a normal logger again, measuring the timestamp, and then it goes back to the experience layer, and I have a time application end. I'll just show you that now that my studio has started up. So here's Studio. Quite simply, we're measuring a logging point before we do an outbound request and a logging point after we receive the response. So there, I've shown you that we can output log, and the log4j, you can configure it so that it has this time in milliseconds. I should just point out what the time in milliseconds is. If you guys are familiar with Unix epoch time, the first 10 digits are the epoch time, and the last 3 are down to milliseconds. So there is a function that will allow you to get the epoch time in milliseconds. So it's always going to give you an integer that's indexing it up. Now, this time in milliseconds has been done by log4j, which is the reason why this time for milliseconds is slightly different.
So
about
I've done a little bit of timing stuff, and I couldn't find a raise hand button, so I just jumped in. And I would encourage anybody else with questions to do that, since we don't have a raise hand button in our new software. So I did some time. You captured that in DataWeave, right?
Yes.
So
here's the data weave.
Yeah.
There is a function called a DataWeave util timer.
Yeah.
And the current milliseconds is the one that you want to use.
Yeah.
So you can see that it gives you the epoch time, and if I post that again, oops,
it'll do a new one, right?
It'll do a new one.
So my question is, I've needed sub-millisecond timings before, and the only thing I could find was nanos. I couldn't find anything with, and I had to do a whole thing to get the nanos. Have you had so would that be? I know that would be probably a waste for your logs, but if you were trying to do like code timings or something, you'd need nanoseconds, right?
I would say nanoseconds would almost be too fast.
It's a lot. It's a lot, but I couldn't get micros, so the only options were milliseconds or nanoseconds that I could find in DataWeave.
Yeah, I'm afraid that's all I found as well. This current milliseconds is the DataWeave function. There is another way you can get it. If I just open up my log4j. So here's my log4j, and I am outputting to Datadog, and there is a ability to use milliseconds in here. Ooh, where's it gone?
Yeah, go slow. I see it right there.
Yeah.
Stack trace as string and then include time millis. I had to zoom in. That's why I'm saying don't take the screen away. People are probably zooming in.
Okay, made it a bit bigger. So you can see the include milliseconds within the. So if you're doing a file output, the include milliseconds will give you the milliseconds. If you go into Datadog, you can include the milliseconds. And if you're just outputting to the Cloud Hub appender, you can also set it to a JSON layout and include the milliseconds. So milliseconds equals true. So that's how I get the milliseconds. I'm using log4j to do the outputs, and I'm using this function here, DataWeave util timer, and current milliseconds to get the same milliseconds. And what that's giving me in Datadog is a number of logs. So this one's the experience layer. You can see a difference between the time in milliseconds from the log4j to when you actually record it in DataWeave. You can see that in DataWeave, we got to 873, and then the logger injected it at 841. So what that means is that, going back to the application, the time it takes for this DataWeave function to run, which is inside this logger, here's the DataWeave. So it's using the time util, it's capturing the current milliseconds, but then it posts to Datadog via log4j, and there's a few milliseconds difference. So just running that DataWeave within the logger, and then the logger firing and sending it out to log4j, is giving you a few milliseconds difference. So that's the reason why 873 is smaller than 941. There's a 70 milliseconds in it.
But I wouldn't blame all 70 of those milliseconds on the DataWeave execution, because loggers are asynchronous, and it has to make it through log4j to the appender before the appender is going to record the millisecond. So there's DataWeave computation, and then there's the log4j plumbing, and then there's the appender. So all of that added up to 70 milliseconds.
So really what I'm showing is that if you're going to put, in this example, a logger at the beginning and end of flow and try to measure the difference, you are measuring not the true beginning and end. That's really what I'm pointing out.
Right. Yeah.
And I saw in this project in Germany that people were putting loggers in and they weren't capturing milliseconds. They weren't aware of this function, but they were trying to capture timestamps and end stamps, and they were trying to
Yeah.
work out the timing flows. But my boss said to me, I'm more interested in what, here's the external traffic going in now. I'm interested in what is the timestamp at the beginning of the application? How long does it take for the application to process it through its flow? The outbound call is made. It's processed, takes a bit of time through the outbound call, and then it goes back. What's the response time from when it's sent and received, and the response time to go back? So he was wanting to know what the milliseconds through the whole journey. Is there latency between the applications? Is there latency across the applications processing? And obviously, it's a bit hard to measure external traffic because it's hard to get the same timestamp. These applications are all running within the same environment, or they're running on Cloud Hub, or they're running on an on-premise Mule server. So the timestamps that you collect are going to be from the same system at least. So what did I say to them? I said to them, right, we've got this function in DataWeave that we can use, and we want to add some timestamps. So first of all, I start with this hello world, and what can I do about it? Well, I could go into things like API Manager, and I could assign a message logging policy. So here I am in this application, in this policy. I've got a message logging policy that I haven't enabled. I'm going to enable it so that it just runs in the background, but I'll show you the configuration. What I've done here is import the same DataWeave util timer, and then I've created a JSON output, and I'm measuring the inbound timestamp, giving it the current milliseconds, and just giving it a label performance logging so that I can find it again in Datadog. So assuming that that policy has now been enabled, I can just verify it by having a look at the logs in Runtime Manager. It takes about 30 seconds. You can see that it hasn't done it just yet. Oh no, yes it has. It's applied the logger. There we go. It's applied the implementation.
Yeah.
So now if I do the same call, so if I get my Postman up and I do the same call, I'm going to expect to see some more logs. So the same call, but this time in DataWeave, in Datadog, instead of seeing 4 loggers, we should see a couple of extra ones. I've measured the input and output time. So if I go back to visualize, I'll just explain where I've put the policy and where I'm measuring. I'm using the message logger, which can only do inbound and outbound. So on this Hello World app, when it comes in, it's measuring the timestamp. When it goes out, it's measuring the timestamp. It's not measuring across the application. But because this application is returning a response and not going down to a further system layer, the difference between the input and output will be the time that this takes to process. So if I go to Datadog now and just refresh that, you can see I've got a number of logs. I'll just zoom in on them. Yeah, easier to. It's the last 15 minutes. Datadog's not so easy to use. Right, these 6 are now what I've got. So 4 of them are the original ones, the application logging. But you can see I've got 2 extra performance logging labels. So I labeled them differently just so that I could pick them up. So first of all, we have an application log at the experience layer. So this is the experience layer, the proof of concept, and we've got an application start. The next one is giving me a timestamp when it was inbound. Then we have a logger inside the application and a logger on the outside, a timestamp on the outbound. And did I put no, this one, sorry, is the time on the outbound. So I could create a dashboard where I'm looking for the timestamp outbound, that milliseconds, and the timestamp inbound. And I could do one minus the other, and it'll give me the milliseconds that the application took, hello world. So what I've shown you here is that we can use the standard policy from MuleSoft, the message logger, to be able to measure an inbound point and an outbound point. Now with the process layer, that's okay because it goes in, goes out, and returns the call. So we've got an accurate measure of how long this application takes. But what if I wanted to measure the inbound timestamp here, but then I wanted to measure the outbound, then how long it goes to the process layer and back? You'd want 4 points, 4 logging points. Now, the message logger, the standard policy, will only do inbound and outbound. It won't do outbound calls. But Ryan's a useful kind of guy. He'll teach you how to do custom policies. And if I switch my workspace, I'll show you too how I've created a custom policy. So I extended the message logging policy to be able to measure the timestamp before on an inbound call, on the request outbound, the response outbound, and then returning the inbound call.
That's a very new thing that policies can even do, is be able to govern outbound calls.
That's right, and
Yeah.
not many of the policies govern outbound at all. You get shown it in the production ready integrations course, but unless you're creating custom policies, none of the standard policies really do it. Almost all the standard policies work on the inbound flow and on the outbound response flow, but not on the outbound request to other layers.
And I
So
just want to have it as everybody's connecting this to a Mule application. Inbound, when Francis said, that means the listener. Outbound, that means the request.
that's right.
Yeah.
So I've switched my workspace and I'm going to show you what I created. I created a template policy. So when I did the production ready integration course, I could create a custom policy from an archetype, but I decided to create a generic one, which just explains things better. There's only really 3 files in a custom policy: the POM file, which I have a standard POM that works. I can just edit the name, and then I can copy this application, edit the name, and I can quickly spin up a new custom policy. I then have a YAML. The YAML file just describes what goes in it. This is just a generic one so that I can use it as a reference to teach me to copy and paste bits and pieces. And then there's a template. But the template is what I want to show you guys, because it sort of explains where the flows work. So before an API call, so on the inbound listener, you effectively have a flow that is enacted before you receive it into the application. When it goes back to the web client that called you, it's this after API call. And then if you have any outbound requests, this is the flow that enacts before the outbound request, and this is the one that is the response. So this is what I use as a template, and typically I'll be editing headers. So when I created my performance monitoring policy, I did this. Where's my performance monitoring when I want it? That again. I changed my template to use the same 4 flows. So before the API call, I did some things like measure the time. So I've imported that util timer, and I've just grabbed the seconds and saved it to a variable. And notice what I'm doing here with the custom policy. I was aware of the Uber threading model, so I made sure that I just use set variables, because these components use the CPU light thread. Flow references use the CPU light thread. Remove variables reuse the CPU light thread, and the loggers use the CPU light thread. So I was keen not to use any data transform components because they would use the CPU intensive. I just wanted this policy to run really quickly capture variables, remove the variables afterwards, but log output either by log4j or through a HTTP requester, which was a further iteration. But essentially what I'm doing is recording the time before the call. I'm then setting a correlation sequence, because one of the things that we find with if I go back to the logging, is that you don't always get logs in the same order. So if you're building dashboards, the first logger may be the application one, then you get the outbound, you get the performance one, which was at the process layer, but then we get the application log before we get the process layer outbound. So these logs don't always receive into Datadog in the right order. So how can you?
Is there a Datadog date that's different from your data we've calculated date?
I think it's just when it's ingested. So this is looking at this example here, this performance log here, that is timestamp 2569, should have been before this application logger, which is that one, I think. Yeah, it should have been before this one, which is 2589. So you can see that 2589 is exactly the same time, but the time that is ingested is different.
I had a whole stack I did on Splunk years ago, where we were able to repair the way Splunk computed its log dates. But I had to do it on the Splunk side. There was nothing to do in Mule for that.
Well, what I've done in Mule to try and order these logs in the right way is to put a sequence number in. So this policy is going to apply to the experience layer, and I'm going to put a sequence in. So I want the sequence number 1, for example, to be on the inbound, and then on the outbound, I'd want to have 2. So what I've done here, if I show you visualizer, is I've recorded a sequence number. I can change it to a label if necessary, but the sequence is 1 for the inbound, 2 for the outbound. If it was applied to a process layer, it'd be 3 for the inbound, 4 for the outbound. If it was applied to a system layer, it would be 5, 6, and then reverse order 7, 8, 9, 10, 11, 12. So I put sequence numbers wherever it's been applied.
That's reliable. I like it.
Yep. so if I just show you what I've done, if this policy is applied to experience layer, it'll be 1, 2, 11, 12. If it's applied to a process layer, it'll be 3, 4, 9, 10. If it's applied to a system layer, it'll be 5, 6, 7, 8. That's the way I wanted the sequences. And when I apply the policy, and I'm going to show you how I'm going to apply the policy and then go back to just describing it. So with the experience layer, I've applied a generic API instance to it rather than one specifically. So this API instance gets applied to lots. But in this performance logging, I'm going to switch it on, but I'll show you the configuration. I have got the ability to choose whether it's an experience layer, process layer, system layer, or a backend, and that sets the sequences in the log.
Don't go too fast here. So the reason you get to choose that is you coded that in the custom policy.
That's right.
Mm-hmm.
Yeah, in the custom policy, if you feed in one of these 4 values, so experience, process, system, or proxy, you will set an array to be 1, 2, 11, 12, or set an array to 3, 4, 9, 10, or set an array to 5, 6, 7, 8.
Well, now you got to answer what the last one is. What's the proxy API?
I'm future proofing.
Okay.
I'm also just being a bit vain. These drop down boxes, they are configured by a radio. And if you have 3 options, they show up as a radio choice. If you have 4 options, they do a drop down.
Got it.
I like drop downs. So yeah, it's the same with this one. At the moment, I've got 2 options for logging, one via Log4j, one via Datadog, HTTP to Datadog. On-premise was having problems using Log4j because they didn't know how to set it up correctly. So in the past 3 weeks, I've been setting up these 2. I haven't set up Splunk or the None yet, but again, I just wanted 4 options to make this into a drop down. So those are the 2 options that I've done, but we're going to use the standard Log4j. And you can see I've been doing a lot of coding because I've been testing a lot, and I'm up to version 58. But that's what I'm doing here. I'm selecting this as experience layer, and I'm going to output via Log4j. That's been applied to my generic instance. So that is now enabled. And if we look at the runtime manager of my OAuth module proof of concept, you'll see that policy should be applied now. So here's my OAuth module and the log files. And you'll see that this policy, version 1.28 and the implementation 1.28 have been applied. So the effect that that's going to have now is add some more logging points. So without the standard message policy on the process layer, I was getting 4 logging points. With the standard messaging policy, I got an extra 2. Now I want to see an extra 4. So if I go back to my Postman and make that general call on the experience layer, I've got my response back. And in Datadog, I should see an extra load more logging points. So we're going to concentrate on those logging points. It always does that. It never shows me. Datadog takes a while to index, and so I'll stick with this. So we are showing the older logs, but here are the extra 4 logs. So I had 6 plus 4. There should be 10 logs here, which are these calls here. This time around, you can see performance logging, you can see application logging. So ignore the application logging. They're the ones in the experience layer. It's these performance logging ones that I'm particularly interested in. So the first one I click into that. I've added some extra details. So I've output JSON, and then I've appended some extra JSON. So when you append two JSON objects, it merges into one. So I've worked out, here's the sequence. I've given the correlation sequence, version 1, for the policy. So in Visualizer, at that point corresponds to here, the inbound call here. So the inbound call into this experience layer is sequence 1, and I've got an inbound time. Obviously, you can see that the time it actually got logged is different, but that is the time that the application thought it was. I then go to my logger that's within the application, so that's an application logger. Then it makes a call out to the application. You can see that this is correlation sequence 3, so that's the one actually in the Hello World application rather than the outbound. But if I click the next one, or even the next one, you should be able to see number 2 should be in here somewhere. There you go, there's number 2. So you can see number 2 wasn't in the right order, but with having the sequence, even though it got ingested after the process layer, it's got an accurate outbound request timestamp, a sequence to say whereabouts it was, the fact that it was outbound via a policy on the OAuth proof of concept. So first log is there, sequence 1, second one is there. Then we go to the third one, which I think was here. Yeah, third one here. So you can see that these are out of sequence, but you can use this sequence number to bring them back into sequence. And by creating the timestamp at the exact points within the policies, you are now getting proper timestamps here, 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 the response return there, and back again. So why have I chosen a custom policy? Why did I even implement it? 2 reasons. When you have a custom policy, you can enable it and disable it. So you can be interested in performance monitoring when you want to be interested, but if you don't want to load the application, you can switch it off and it's applying no load to the application. And when you have an application, you can apply a number of policies to it. So this application could have a security policy, it could have an IP whitelisting policy, it could have a JSON threat detection policy, it could have a load of policies. And when I applied my performance monitoring, I made sure it was the first one in, last one out. So it's measuring the true beginning of the stack of flows and the true outbound time, because it's the first in, last out. So I've made sure that the policy is number 1 in the sequence order. So if you have loggers within the application, you'll be measuring after it's done authentication, after it's done IP whitelisting, after it's done other flows that are part of the policies. So I felt that that was a second benefit of using a custom policy, or measuring the true inbound time and the true outbound time. The other thing I wanted to do, which I can show where did I put it? One with duration. So number 2, I'm looking for number 2 again. So when I measure the inbound and outbound, I want to know how many milliseconds it took to go across that application. And the true time is the difference between sequence 2 and sequence 1. So I know that sequence 1 is here. There's the milliseconds, and there's sequence 2. And because I'm within the custom policy, I can work out the difference. So I have worked out the difference, the duration, and I've added that. So that timestamp request outbound minus the inbound is 125 milliseconds. So I'm able to add extra attributes with the custom logger so that I can show you that going across that application, if I have other policies enabled, you might see that actually go up, that 125 milliseconds.
That's, by the way, that's a lot of milliseconds for an API call. Yeah.
Yeah.
I want to know what's using them up.
Exactly. Then it's the same on the return. So if I look at the return, point 11 is the difference between the outbound call. So the outbound call is 0.2, and the inbound, the response, is 11. So because I'm within the custom policy, I can take 11 and I can minus off sequence number 2, and I can get a duration of response. And I can see that it's 277 milliseconds. So that is effectively working out the time it takes to go outbound here and respond.
So I might have not been paying close enough attention. I was expecting the first number you showed us, 100 something, to be bigger than 227 because it included the 227, but maybe I wasn't understanding where you were making the measurements.
I was making the measurement at the beginning and the outbound. So
Oh,
just the time it took to go across that application.
yeah, not all the way until the response. So I
No,
got a request to I sent a request was
yeah.
100 and something, which
So
is a lot.
so the inbound and outbound 177.
Yeah.
I can do this again. It'll probably be quicker. If I had caching on and things like that, you see less
Yeah, but
logging.
you need to see that because like the cold and the hot are going to be different numbers. So that was great. That was good.
Exactly. But really, what I'm explaining to you is that the custom policy gives you the feature of being able to switch it off and switch it on. When it's on, it gives you the ability to get sequence numbers and measure the exact points you really want to measure. And then because you've got a custom policy, and I'll take you back to the custom policy and show you the design, if you measure the time on the inbound, which I have done, you can then, before the API request, work out the input duration, which is basically the input time minus the request time. Then when you send your request out, you can get your response. So here's my response. So here's the timestamp when I return it, and then my duration of the response is basically I sent you at this time, I received you back at this time. What's one minus the other? Log that out, and then finally the same here, the app duration on the way back. So measuring from point 11 to 12. But so I minused off the response time. I did the input and output minus the response time, just to give me the time back across the application. Say I was doing a transformation, say I was doing some normalizing of the attributes, say I was doing some masking. Those sorts of things would influence the response time on the way back. So essentially, I'm measuring the flows between applications, or the total flows used to go into an application, the total flows out. And that's the beauty of custom policies. With the standard message policy, I can only measure the inbound and I can only measure the outbound, but I can't get one bit of configuration to talk to another bit. I can't set a variable in the inbound so that the outbound bit can read it. So that's a limitation of the standard message policy. By having a custom policy, you're able to create variables and use them on both the inbound and outbound. Whereas if you had things like HTTP requests and you're measuring before and after, unless it was within the same flow, in the same application, it's harder to measure. So that's really all I was trying to show you, that I'll just put this performance logging. If I filter by performance logging, I'm just showing you the performance bits now. So there's 6. So you can see a inbound 0.1. You can see the inbound on the process layer. You can see the outbound on the process layer. You can see the request on the experience layer. So the sequence numbers are important because they put them, it allows you to build a dashboard in the right order. You've got a common correlation ID. So this correlation ID is common to all of these. So you'll be able to build your dashboard from the correlation ID. You've got your host or your service, and that allows you to see how it flows through the system. One thing that I did get asked was how you could see which flows, which outbound flows and inbound flows were used. And the thread information does contain it, but you'd have to do a regex, and you'd have to have some sort of convention on your naming of outbound flows to be able to capture the right thing. So you can see this is you can see from the thread information that some of it tells you where it was inbound from and where it was outbound to. But that's my next step on building dashboards. The important bits were the sequence numbers, the time it takes to go across the applications, the real timestamp that's inbound rather than the time it was actually logged, and then other information just comes with the log anyway to be able to build the dashboard. So that's what I managed to throw that up in about 2 days and apply that.
So that's where you are in the process. You have not yet made the dashboards. You're in the middle of it.
I have learned Datadog for all of 1 week.
That's amazing. That's
I've
amazing.
used Splunk for 2 years, but we've got a whole Datadog team that are keen to perform performance metrics, but they were trying to measure logging points within the application. And I said to them, wrong. You're going to be applying policies to do masking, to do authentication. That's going to affect the time it takes the overall response. So it's important that, so I'll take you back to API Manager to show you what I mean. So within an application, you can have a number of policies applied. So it's to do with the order. You can see that this message logging is first, but if you had a number of security policies or rate limiting, if you had another custom policy for making certain endpoints unavailable, if you had authentication or caching, or if you had any like masking or standardizing of keys policies, all of these policies are flows. So when you go into an API, the first policy will be a flow that then passes on to the next one, which is a flow, passes on to the next one, which is a flow, passes on to the next one. And all these are cumulative. So if you have a lot of policies, you've got a lot of actual extra flow duration to add to your application. So logging within the application, unless all the code is in the application, you're not going to be measuring truly everything. So if you had your authentication within the application, yeah, you could probably measure your true input and output.
But then Francis would fire you if you had your authentication in the application.
Exactly. You should say that. But yeah, that's really what I'm showing you. The requirement was we want to measure the timestamp of inbound and outbound. To do that, I had to make people aware of this lovely little function. As Ryan said, there's nano and seconds out there. You can get epoch time of servers, but we were looking really for something that was functional across different servers. We've got Linux servers, and I wanted to make sure that this ran on Linux servers or that it ran on Cloud Hub. And yes, this function is utilized everywhere, and I can even use the timer of milliseconds in Datadog itself and do comparisons. So this is a useful function to know. There's a few others within this utility. I recommend that you go to the MuleSoft documentation and have a look it up. But this whole functionality relied on knowing an integer with current milliseconds.
Can I add on there? I think for the timer module, if you need to measure timings within a transformation, like if you've got some big data weave transformation and you want to measure the functions, there are tools in there that you can get timings even inside the data weave, not just in the Mule application. So I don't know, it doesn't sound like you needed that yet, but that's why people might want to investigate it.
You might want to investigate if you're starting to build data weave libraries. That's a whole other topic. But yes, as Ryan said, I did have a look on YouTube and I did find Alex Martinez doing a few videos about the data weave functions and measuring them. But in those cases, they weren't useful to me. I was really after an integer and I was really after milliseconds. So that was the function that helped me out. So I have answered the requirement. Datadog team are still building. I literally only delivered this last week to them. They're building dashboards. I can change things. I said to them, if you want to have a different label, I can change it from like performance logging to something else. If you want to have it at a different level, if you want to debug rather than info or warning, I can change that. If you want to add any other information, you'll notice that with the logger names, I put a category in just to separate the loggers out. So I use the categories as well as the label to separate the logs from application logs or from any other logs, Mule logs, for example. But yeah, they have the fundamentals of what they need. That sequence number I could change to, rather than just a number, I could change that to like an inbound request, outbound request, inbound web client. I could use a different verbose word if they want, but for just functional purposes, I just thought a sequence was easy to see how it was going up.
And I don't know if did you ever code BASIC when you were young? You run out of integers in the middle, so if luckily with this you could use 11.5 or 10.5 if you needed to measure something at an interim point.
Exactly. Well, this hasn't gone live yet, so I've got the ability to change the numbers where necessary, but they just needed a rising sequence because, as I showed you here, the logs just come in any sequence order, depending on when they get sent by log4j in an asynchronous form. So you can't rely on this timer milliseconds in the logs. You have to actually measure it within the application or within the policy and send that value.
Mm-hmm. So what else? Because I'm holding some questions.
You can ask away. You can ask away.
I mean, are you guys Titanium?
No, we don't have monitoring or the functional monitoring or the Titanium. I think Titanium is quite a big jump from Platinum.
It is a lot more expensive. So one of the nice things that they added to Titanium is called tracing, and it does kind of this. It does sort of like this, but it makes a picture so you can see the different swim lanes and how long things take. But if you don't have monitoring, if you don't have titanium, that won't show up in your monitoring solution.
And if you
And
have them like I do and switch to troubleshooting view in Visualizer, you
yeah,
can see the milliseconds, the average milliseconds. So these metrics are fired from Runtime Manager and API Manager, and they're added together in the dashboards. So this isn't giving you the time of those individual calls, so you can't drill down. It's just an average.
yeah,
So
and with now that you got it in Datadog, you can do 99th percentile, you could do median, you could decide what statistics you want. That's pretty good.
exactly, and that's why I chose it like that. So it it didn't take me too long to figure out that's what they wanted, but choosing to do it with custom policy, I had a few other problems, such as putting custom policies onto a runtime manager instance that's inside a proxy network that couldn't connect to the control plane. And yeah, I've had a load of other problems, but I don't want to bore you with those ones. Crucially, you need to know that custom policies can be switched on and off, so you don't load up the application. They can be measure the true input and true output, and they can
Yeah.
also work out the durations because you're able to store variables before and after a call is made.
So there was a question in the chat that it sounds like I know what your answer is going to be. He was asking, what about scheduler driven processes?
I haven't thought about scheduler driven uh, things, but there's no reason why it can't measure that. I mean, it's just the inbound request. The only thing to be aware of with custom policies, this inbound and outbound, I think you can only measure database outbound, HTTP, and Salesforce. I don't think it has. When you're measuring this outbound request and response, there's only the
Yeah.
standard connectors that you can do.
But
So
but for that you can basically add one option you have is you can add REST adapt. You can make a REST API in front of whatever it is that you're trying to call, and then the policy can speak to it. Or your other option, I guess, is people can go back to adding loggers in in the Mule code itself that are compatible. It's
exactly, I
it's
was
not
just
as nice because you can't switch them off, right?
yeah, I was just about to point out that if you're using scheduling, chances are you're connecting to SAP, you're connecting to something esoteric on the back end. You've got a custom connector, in which case you wouldn't be able to measure this outbound because I showed you first the standard message policy, and that can give you some information, but only the two measuring points. The beauty of the custom policy is that it does measure this outbound request and response, but it only works for Salesforce database and HTTP. I've only tested on HTTP, so I can't guarantee that it's going to work on the other two, but I believe
It's
that's the
strange.
case.
I've noticed that Visualizer can measure SFTP, but I guess maybe the custom policy can't.
Maybe it can. I was just reading off the documentation, and as we know, documentation is not always 100% right or up to date.
No, this was fascinating, and I would love to maybe after you have time to cook the Datadog side a little bit, it'd be cool to see the dashboards that come out of this.
Yes, yeah. At the moment, you're just imagining the data, what it can do. Now, send another request. What I did show with other people, you know how I said that this was an OAuth token. This experience layer needs to grab an OAuth token. If I was to delete the tokens stored in my object store and force it to do a token request, you'd see the response time increase. Without a token, the response time was about 300, 400 milliseconds, sometimes a second. With an authorization token, the response was much quicker, down to like 200, 300 milliseconds. And then I've been testing things like adding masking policies, adding a normalization of the attributes just to see what impact they have as well.
What else? The people still here? Put in the chat any more questions or observations or comments, or you can come off mute also. This is
Yeah,
a cool topic.
I mean, I'm showing you a lot of things here, like with loggers. Do many people remember to change their categories? So I'll show you a log here. You see this. Where's it gone? Not that one. You see this logger name. Are people familiar with those logger names and how they get output within the code? So if I just show you some code, here's a logger and the category there. That's how I differentiate them. So I tend to call my loggers in policies, com SGUK, which is my company logger policy, and then within the application, com SGUK logger application. So populating that category field is what gives you the different logger names. So you can see that the logger name there, that one obviously hasn't been set because that's the standard one that you get if you leave that logger name blank. Oh no, no, to the right, that has got the com logger policy. I don't know why it's so long though. So
Yeah.
Policy.
Yeah, it's always a lot better, a lot cleaner when you intentionally set your categories.
And there's also you'll notice that these are all info level. Within the applications, what I've also done, this is to do with log4j. If I take my experience layer, so this is my experience layer, here's my settings. I've got my logger levels, and these are the loggers that I just showed you, the policy ones and the application ones. Anyone want to guess how long it'll take me to change this logger level? Is this application going to redeploy?
Are you on Cloud Hub 1 or 2?
I'm on Cloud Hub 1.
All right. Anybody want to
anyone want to guess how long this is going to take to change? So if I want to get rid of these policy logs and put it down to info and press apply changes, how long is this application going to take to redeploy? It's a 0.1 vCore. Well, I'll just press apply.
Quickly.
You'll see it changing, and yeah, it's back.
Oh. I have to warn everybody. That's one you lose that when you go to Cloud Hub 2.
Yeah, that is true.
It's too bad.
It redeploys.
There's a reason why this was quick, because if I go back to my log4j that I showed you, within the loggers, I have all the classes for all connectors listed. If you look at GitHub and borrow other people's log4js or use the standard one that comes with the project, you'll find all the loggers aren't listed here, all the classes. By having all these classes listed, even if I don't use them, so let's say Cloud Hub extensions, so let's grab that one, SQS, even though I'm not using it. There's a monitor interval, so every 15 seconds it's looking for changes in this document. So when I go to logging and I add a whole new class, you saw that it does exist in the log4j for this application. So if I apply that, is it going to redeploy? Well, if you don't have that class listed, yes, it is going to redeploy. But in my case, no, it's back.
Ah, interesting.
So
I think I've seen. I don't think it has to be in the log4j. I'd like you try just my name. I think it will still not redeploy on Cloud Hub 1.
I am not. I think it may do.
Well, let's find that. I'm willing to be wrong.
Oh no, it has come back. I have found through previous experimentation that if I didn't have the class listed, that it would take a long time. I'm not sure whether it's the fact you've got the class. I'm not sure if it's the fact you have all of these. Oops. I'm not sure if it's because I list every single one of the classes that it did it, or whether it's because
The
I'm using
monitoring
the monitor interval.
Yeah.
I think it's because it knows Ryan. It picked up his name and it was like, oh yeah, it's Ryan.
I've not put monitor interval in my log4j XML. I still think Cloud Hub 2 is ignoring it.
Give it a go. Well, you can. The reason why I use Cloud Hub 1 is so that I can disable the Cloud Hub logs and use my own log4j, and I have the monitor interval on that log4j.
It's a bit of a migration to get to 2, and you lose some things. So,
but as you can guess, what I did here by setting that policy to info, I'm now not going to get any I'm now going to get more logs. If I set that up to like error, those performance logs that I got, they're not going to show up. So even though I have the performance monitoring policy applied, because I've said only show me errors and above, that policy was set at info level and it's not going to show them. So this is the way that you control the amount of verbosity of the logging.
Awesome. Wow. This is great. I cannot wait to get to this, to send this video out to everybody. This is good. Any other questions from the people here? Man, I appreciate you coming in and doing a study group with us. This is fantastic, and I have to say it's nice to have once in a while something that's not about AI.
Well, like I say, this is the sort of thing that you can expect people to ask when they're pushing for operations. I mean, one thing I find, people are familiar with the DevOps cycle. Well, most of the time we just have dev, 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 and we have proof of concepts, and we have proof of concepts going into production because operations teams aren't putting their non-functional requirements into the design.
Right. Yeah.
And what I'm showing you here is exactly that. The operations team need to be able to build dashboards. The operations teams will get questions on performance, and they'll need to drill down and look at what's the difference between yesterday and today.
Of course. Yeah.
So it's those
And
operations.
later, 6 months from now, when all these numbers change and you don't know why, you'll have them.
Exactly.
Yeah. Yeah. All right. Well, thanks. We're gonna wrap. It's almost 1 hour, and I have a meeting. So appreciate you doing that, Francis, and I hope to see you in the next one.
Yeah. Okay.